All right, so let's take a look at this chapter 10 practice test. The first question here says Susan is trying to solve summation, and I give you the summation right there. Using the formula, the sum is equal to n divided by 2 times a1 plus an. She substitutes the value n equals 10, a1 equals 7, an equals 33. Discover the sum. What can be determined about Susan's work? So there are 4 types of problems that we covered in chapter 10. Would this be summation in terms of arithmetic, in terms of geometric, or would this be the binomial theorem? Which of the 4 would you categorize this into? Summation, meaning the sigma. If you know how to use sigma, you can get this question right. So first, if I type this in the calculator and it will produce a number, what will that number represent? The sum. Okay, go ahead and type that in. See what you come up with. I'll do it as well. You can type the letters SUM. You can type in, well, my computer's frozen. There we go. You can type in SUM and it should give you the sum symbol. Or you can press functions and scroll down to calculus, which is what I'm going to do here. So I'm going to change this to a K. K equals 5. That's the lower bound. The upper bound is 14. And inside parentheses, I have 2K plus 5. I'm getting the number 240. So what does that 240 represent? The sum. The sum is 240. So I'm going to go ahead and put that over here. The sum will equal 240. So let's see. What did she get for her sum? 200. What does that mean? Did she do it correctly or incorrectly? Incorrect. So go down to your answer choices. And if she did it incorrect, which one can we eliminate? D. She did not do it correctly. Therefore, D is wrong. She must have made an error somewhere. She did make an error. So that one's out. So to determine how she made an error, you have to know the process of sigma. So how, if you did not have a calculator, how would we solve this? If you did not have a calculator. That's right. You take the lower bound and you plug it in. So let me move this away. That eliminated answer choice D. So what you do is you take the lower bound and plug it in. This will give you A1. So I'll write it in line here. A1 would equal, you don't plug in a 1, you plug in 5. So this 5 goes into the place of K. So it'd be 2 times 5 plus 5. What is 2 times 5? 10, add 5 more? 15. So A1's supposed to be 15. She got A1 equals 7. Appears to me that's her error. Appears to me that's the correct answer right there. She got 7. The correct answer is 15. Let's just check the others. What would AN refer to? A14. Not necessarily A14. What should we think of when we see AN? So I don't want to confuse you, Eric, because you're on the right track, but it's not this. Let me say it this way, Eric, to correct yourself. A1, did that mean I plug in a 1? What did I actually plug in? 5. Now, why did you say the number 14? Okay, so AN, you are plugging in the 14, but that does not mean it necessarily that it's A14. In this case, it actually will not be 14. So when I plug in a 14, it would be 2 times 14. So AN means last term. If you're looking at it this way, solving, it would represent the last term. What is 2 times 14? 28. You add 5? 33. Is that what she got? So she did that part good. That part was correct. And then this n does not equal 10. What does n refer to? The number of terms. Now, how can we determine how many terms there are? You start at 5 and count your way up to 14. Good. So K could equal 5, 6, 7, 8, 9, 10, 11, 12, 13, and oops, forgot the 1. 14. How many different K values do you see there? Count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, n equals 10. So that's what she got. That's a good number. So that's how the process of sigma works. So you need to know how to use sigma. Any questions on number 1 before I move on? This problem I gave you here was to test if you understand the process of sigma, Oscar. So no other takers? One more. I'm gonna come back here. We said earlier this is possibly A14. I said that's incorrect. It's not A14. Now that we've worked through the whole problem, what little number could you replace the n with? 10. N is 10. You could call this A10. Because that's how many total there are. It's not because we plugged in a 10. Wrong. We plugged in a 14. It's A10 because it's the 10th K value listed. Okay. So a quick way of knowing how many terms there are is that you take the 14 and you subtract by the amount of K's that have been skipped. If you start with 5, how many K values did you skip? We skipped 1, 2, 3, and 4. We skipped 4 K's. So you could just do the upper bound minus the numbers you've been skipped. We've skipped 4. So 14 minus 4 is 10. That's a quicker way than writing out the full list if you want to do it that way. Okay, let's take a look at number 2 now. So again, there are 4 concepts. It says, what is the sum of the geometric series if it exists? Which of the 4 categories would you place this in? Sum, sigma, an nth term of arithmetic, nth term of geometric, or the binomial theorem. So this symbol right here tells you that's a sigma, a sum. Now this one, it just says, what is the sum? So how could we do this one? You can plug that in the calculator, because what will the calculator give you if you type this in? It will give you the sum. So go ahead and type that in, see what you get. Oh, there's gonna be one problem with the calculator. What's our problem? The infinity. Desmos doesn't handle that. So what if I told you to do, put 1,000? Put 1,000. So again, I'm gonna go to, you can type in sum. If you type it in like that, it'll give you the sigma, or you can scroll down after pressing functions to the calculus section. And there you'll find it. N equals 1. The infinity won't work. I can show you infinity. If I type that in, it'll give me the symbol, but it will not work here. So it gave me no answer because of that infinity. And I think that might be what this summation bounds must be finite numbers. Finite means not infinite. So I told you to use 1,000 in place of it. Something large like 1,000 will work. I press 1,000. And this is the number it's giving me. I don't see that number there. What can I do to turn it into a fraction? Yeah, where's the fraction button?
The blue.
And the blue right there. It says 32 over 3. So the answer is B. There is a formula on the formula chart for this. I haven't even opened up my formula chart. Let me do so now. While that loads. There is a formula you can use on the formula chart, but I think the calculator is just as easy, so. With that, I'm moving on. Problem number 3. Any questions on this one? So how many types of problems might you see? 4. We've gone over how many of those types? Just 1. We just went over the sigma. All right. Well, my computer's frozen. All right, now that my formula chart is loaded, if you are on this side of the formula chart, you go to sequences and series. You could also use sum of that was geometric and it was infinite right here. You could use this formula, A1 divided by 1 minus R, and that could solve the problem for you as well. All right. Number 3 here. It says the first 3 terms of a sequence are shown. What is the sum of the first 51 terms in the sequence? So this is either going to be a problem that goes with the nth term of arithmetic or nth term of geometric. We don't know which yet, but anytime you have a sequence or series like this, sequence or series, you're going to be using one of these 2 formulas shown here. You'll be using one of those 2 formulas. So let's determine if it's arithmetic, meaning you have something that's adding or subtracting common, or geometric, multiplying or dividing. I start with testing it with arithmetic. I think it's the easiest way. What would you add or subtract to get from here to there? I'm hearing +4. If you don't know, the formula would be A2 minus A1. Negative 79. Negative 79 minus a negative 83. So I have back-to-back negatives there. That turns it to +4. Okay, check it. Is this also +4? Going from here to here. Okay, so if that number is the same that you're adding, subtracting, what do we call this? Arithmetic or geometric? Arithmetic. Okay, that is arithmetic. Now, once you know it's arithmetic, go ahead and copy the arithmetic formula. So once you determine it's arithmetic, copy the formula. It says arithmetic right here, this one. That's the formula I'm going to take. Right there. So I have AN equals A1 plus N minus 1 times our common difference. Now we've already solved for D. D is 4. Let's see, what else did they give us? A1. A1 is -8. Whoops, I forgot to write A1 equals -83. So that's this in the formula. We have that piece. We now have D. Okay, it says, what is the sum of the first 51 terms? What's that telling you? Is that telling you what that AN equals 51? No. What does that mean if it says 51 terms? N is 51. That's the N value. Now it says to find a sum. So if it doesn't give you the sigma, to find a sum, I gave you an acronym. SAND. We're going to look for SAND. To find a sum, you're going to use sigma. You need an A value, N value, D value. SAND is what I'm calling this. Okay, start with, so sigma will replace this portion. Sigma replaces that. You need an A, N, and D. Do I have an A value? Yes, I do. I got -83. Do I have an N value? Yeah, what's N? 51. We have that. Do we have the common difference?
Yes.
Yes. You can solve sum. So what do you always put on the lower bound? N equals 1. And in this case, what are we going to say N grows to become? 51. Now this will add together every single term. So the first term is -83 plus. Now, do I put 51 here? No, because I want to find each term along the way. So the calculator will substitute. Any place to substitute sigma, the N value into. So I'm going to leave that in. N minus 1 times. What's our common difference? 4. I'll put parentheses just to make sure the calculator multiplies that. So if you type that in, you should get your solution. By the way, question for you. Would this still give me the same answer, do you think, if I did not use A1? What if, whoops. All right, I'm going to try this again, if I haven't screwed it all up. All right, something's really irritating. Okay, what if I did this? Would this work if I did not use -83 there? Could I use possibly -79? If I wanted to use -79, now would that give me the same answer? Not yet. I'd have to change something else. What would I have to change? N minus 1 needs to be. Okay, and I'm going to show that to you just to make sure you see that. So as long as you correspond, that being the second term here, you could use that. So we go to type this in. What's the shortcut I could type in on my keyboard to get this symbol? Sum, S-U-M. Or you can just press functions and scroll on down. N equals 1 up to 51. Parentheses -79 plus. Oh, I'm doing the second one, aren't I? Better do N minus 2 times 4. 867. Now I want to try this again, but this time I want to do A1. A1 was -83, but that would have to be N minus 1. Am I getting the same answer both times? Yeah, so it doesn't matter which A term you choose, just as long as you correspond it correctly with the first term, second term, and so on. So the answer here would be 867. The sum would be 867. Sum of the first 51 terms. That would be the symbol for that. Questions on this one? No? All right, let's look at number 4. What is the second term, the 32nd term in the arithmetic sequence? So this time I already went ahead and told you. Don't expect to be given this though on the test. Do not expect to be given this. So how would you determine what type of sequence it is if it's not given to you? See if they add and subtract you the same. What do you have to add from 9 to get to 16? 7. Again, you could just say 16 minus 9. The second term minus the first one is 7. Check it. Is this also 7? All right, so if it's a common difference, then guess what? It's arithmetic. As soon as you know it's arithmetic, what should you do next? Go grab the formula. So go grab the formula. There it is. And this time I want you to solve for the 32nd term. I'm going to write it down. So the formula we're using is AN equals A1 plus N minus 1 times D. I want you to solve for the 32nd term. Let's see if you can do it. All right, so after watching, y'all determine what are we looking for out in terms of the formula? What value are you looking for? AN. So we don't have that, but we do know the N value. What is N? 32. So that would equal, what's A1? 9 plus 32 minus 1 times 7. And this is already isolated. You don't even have to N solve this. You would just type that in the calculator. And what are y'all getting? 226. Did you find the sum? That might have been. So 226. So 31 times 7. That's 217. Add 9. Yep, that would be 226. That's correct. Okay. All right, number 5. An auditorium has 12 seats in the first row. The number of seats in each subsequent row follows an arithmetic sequence. If the 31st row has 72 seats, how many seats are in the 22nd row? So I've told you here, what type of problem is it? Is this a sigma, arithmetic, a geometric, or is this binomial? Arithmetic. So what's the formula for arithmetic? Okay, good. So what information have I given you in the problem? Let's start with the first sequence, the first sentence. Sorry. What is, when it says an auditorium has 12 seats in the first row, what is that telling you? If it has 12 seats in the first row. A1 equals 12. Okay, now it says it follows arithmetic. That's this formula. If the 31st row has 72. All right, where do you think we could put that in there, Jarvis? The 31st row has 72. What is that telling us? Yeah, what is that telling us? Nope. So go back to the first sentence. 12 seats in the first row. We said that means first row means A1. 12 would be what A1 equals. So here it says 31st row. So what is that telling you right there? It says 31st row. What did we say first row meant? A1. So what do you think 31st row means? A31 equals 72. How many seats are in this 22nd row? So what are we actually trying to find? A22. Okay, so when I plug in this formula, at the start, where would I put A1? Where would I put this A1? Right here at A1. I plug it in right there. 12 goes there. Okay, plus. Now, at the start, here's where some students get confused. This A31, where could I put this in the formula? Where would I put the 72? Come on, more people, please. Where do you think I should put the 72? Should I put that in as AN, N, or D? AN is 72. So if I put 72 there, that means what about N? Is 31. So here I'd put 31 for N minus 1. Now, do we know what our D is? So we need to solve for that. Okay, you can insolve where you do y equals the left, y equals the right. So you can type in y equals 72, 72, y equals 12 plus parentheses, 31 minus 1 times D. And you could look, you could zoom out and see where they cross, and the x value will be your answer. But using algebra, which is what I'm going to do here. What is 31 minus 1? 30. So I'm going to subtract this 12. Why am I subtracting 12? Julian, why am I subtracting 12? Why am I subtracting 12 here? What's the 12 doing to the parentheses? Adding. So what's the opposite of adding? Subtracting. So I subtract, what's 72 minus 12, Oscar? 72 minus 12? 60. So 60 would equal, and we said 31 minus 1 is 30D. Okay, and what's the last step here? Divide by 30. Okay, so once I do this, I find out what D equals. What does D actually equal? 2. Good. Now that D equals 2, which is, by the way, where this would have crossed right there, you would have gotten 2. So since D is 2, I can use this formula again, except this time I'm going to plug in the D value. And I'm going to redo this, but now I'm going to have A22 be my AN. So now I'm going to solve this again and make A22 equal, what did we say A1 was? 12 plus, if AN is A22, what is N now? 22 minus 1 times, what did we say our common difference was? Times 2. I'll put it in parentheses so I remember to multiply. So here, we could use a calculator, but I think it's simple math. What is 21 times 2? 21 times 2. 42. And so 12 plus 42 is 54. That is A22. So that would be our answer here, C. What's up? 12 plus 42? That would be 21. 22 minus 1 is 21 times 2. That would give us 42. Yep. Okay, so there's that type of problem. All right, moving on. A ball is dropped from a height of 6 feet. Its return bounce is 82% of the previous height. How far does the ball travel when it hits the ground for the 6th time? All right, what type of problem is this? Each return bounce is 82%. Would this be arithmetic or geometric? What are you doing with that 82%? You're multiplying. So does that make it arithmetic or geometric? This is geometric because you're multiplying. So the ball is dropped from 6 feet and it hits the ground. As soon as it hits the ground, the ball bounces up and then it bounces again like this and so on. And how many bounces did it say? 6? That's 1, 2, 3, 4, 5, and 6. Okay, so it's going to look something like that. It says each subsequent bounce is 82% of the previous height. So take your 6, and what do I need to do to the 6 with 82%? Multiply. You can actually type in 82% of 6 like that. If you do 82%, it'll do the word of, and you can type in 6, it'll tell you the value. Or you can do 6 times 0.82. That both ways will work, and you get 4.92. Now, what's the problem if I just say that's 4.92, and then I do this again? Say, what? Okay, what is 82% of 4.92? That's 4.0344. What's the problem if I just write them out like this and add them up? There is a problem with doing this. I heard something about twice. Whoever said that, can you elaborate? What do you mean by twice? What's wrong if I just add up these values here to get the total distance? What do you think, Anthony? Okay, why would I have to double? because the ball goes up and down. So if you're gonna do it by hand, you need to double each one of these because the ball goes up and down. Do I need to double the 6? No, it only goes down. That only goes down, but after that, they go up and down the 4.92, up and down the 4.0344. So that's why those all get doubled. So this would get doubled as well as that. Now, if you want to write a sigma, you could. What you do is just treat the 6 differently. The 6 is not a part of the rest of the sigma because this 6 does not match. It doesn't go up and down. So I would treat it differently. So I would do a sigma for the other bounces. Now, ignoring the 6, how many other bounces did we have? How many bounces after the 6-foot drop did we have? 5 more. So I would do a sigma for 1 to 5. And what's your first term? By the way, the formula, if I looked it up for geometric, is this. So this is the formula I'm substituting in. You replace the AN equals with sigma. So now what's A1? 2 times 4.92. 2 times 4.92. What's the R? That's right. R is 0.82. Whoops, forgot the point. 0.82. Let me write that again. So 0.82. And then I would raise that to the power of n minus 1. If you type that in, you get your solution. Okay, I'm just going to leave it there. You can type that in your own. All right. I don't want to run us out of time here. So I'm going to stop here. Let me actually check. I haven't done one type of problem. I'm going to jump to here, NCR. It says, what is the 5th term and the expansion of 2x minus 3y to the 7th power? So this is a binomial theorem. This is the 4th type of problem. If you remember on your formula chart, I said, don't get caught lost looking at the whole formula chart. If you go to binomial theorem, that's when there's 2 solutions or 2 values, like a plus b to the power of n. The part you're typing in the calculator is right here. There are 3 portions. There's this NCR, which is going to give you your Pascal number. The odds of winning raised to the number of wins times the odds of losing raised to the number of losses. That's what we use. So that's the part you need right there. So I'm going to copy that down here. And the n minus r and the n, you don't have to have the way they say them. But here's what the formula chart says. I'm going to just write the way the formula chart says it. They do it like this on the formula chart. And that would work. So if you use NCR, if you click on that in the calculator, it's going to give you a parentheses for the NCR. I told you, hey, when you see that parentheses, just think of n comma r. So I'm going to scroll down to the very bottom. It's the last option. NCR gives you a parentheses. So there will be a parentheses here, and I want you to think of replacing that with n comma r. And then there will be a parentheses for the a value and a parentheses for the b value. So walk me through, what would be the n value that goes first in here? What is our n value in this problem? 7. That is n. The power, that is n. So 7 goes right there. I'm going to skip r for a second. I'm going to do the easy ones. What would be the a value that goes in here? 2x. 2x goes there. And what's the b value for right here? Negative 3y. You got it. Negative 3y. Now it says find the 5th term. So here's the way I do it. Starting, the first term would be like winning all 7 games. So that's the best term, is to win all 7. Then the second best would be win 6, then win 5, so on. I'll count all the way down. So it's kind of like the opposite of sigma. I start from the top and I count down, rather than sigma starts from the bottom and counts up. So I start from the top, count down. I want the 5th term. Which number comes up 5th? I agree. That's the 5th one. Since that's the 5th one, that's going to be my power right here. And I can also use that right there. To get this power, you subtract. What is 7 minus 3? 4. This is saying I win 3, so I must lose 4 if I play 7 times. So let's type this in the calculator. There's going to be one thing I don't type in the calculator. What is it that I don't type in the calculator? The x and y, the variables. So I'm just going to ignore the variables for a second. And this should give me my answer right there. 22,680. 22,680. As I look up here, that's the only one that's like that. X to the 3rd, y to the 4th. That's because this is x to the 3rd, y to the 4th. That would be the correct answer right there. Okay. So with that, I'm going to let you get started.